Okay, this is pre-calc note outline 2.3. We're going to start it today. We're going to do long division. Guys, long division, if you guys remember, has the division bar, that division thing with a number outside, number inside. You get an answer, and then sometimes there's a remainder. And so there are words associated with these things. And so the first thing is that the number you're doing the dividing by is we call the divisor. The number you're dividing into is called the dividend. And the answer, when you do division, is called the quotient. Sometimes this quotient has a remainder. Now, when we do this, if I ask you to divide 8 into 25, you would say, how many times does 8 go into 25? 3. And since 3 is a single number, I put it above the 3, right? Or the 5. And then, to figure out if there's any kind of remainder, I would do 8 times 3, right? So 8 times 3, which would give me 24, and I would subtract to get 1. So back in elementary school, you guys possibly did 3 remainder 1. That was 25 divided by 8. Can you guys agree with that? What if I propose, because I know you guys have done this before, that the answer is really 3 plus the remainder divided by the divisor. Is that the same thing? 3 plus 1/8? If I wanted to get a common denominator, I could multiply the 3 by 8 over 8. That's 24. 24 plus 1 is 25, and that's 25 over 8. Isn't that exactly what I'm trying to show? 25 divided by 8. So that's the cool thing. We are going to use more of this style. The style where you guys are placing or adding the remainder divided by the divisor. To do this, we're going to use that 7-step process. That 7-step process says you need to place both of your polynomials, the dividend and the divisor, into standard form. It's important. And you need to use placeholders in the dividend, the part that's inside. The reason we use placeholders is so that we have a column for everything. The goal is to always have a column. Placeholders come into play that if I have a 50-degree polynomial and I'm missing the x to the 4th, it's okay for standard form, but to have a placeholder, I would have to state that there's 0 x to the 4ths. So anything that's not there, including the constant, I always have to have a placeholder. Okay, so you set it up. Divisor goes on the outside, dividend goes inside. 3, this is the actual part of long division. You look at the leading term of the divisor, the thing outside, and you ask yourself, what does it take for me to multiply that divisor's leading term to make it equal the leading term of the dividend? And I place it on top where the quotient goes. But I place it, if it's an x squared, you place it above the x squareds. If it's an x cubed, you place it in the x cubes. Right now I'm being very general. We're going to be talking about some examples. I've got about 4 of them that we're going to do today. These are just very generic steps that should always work. Once you have that number, that thing that you guys found to make them equal, you placed it on top, and then in step 4, you multiply it through. Hey, didn't we do that with the 3? I found 3, and I multiplied it to 8. So now, if it's an x squared, you take that x squared and you distribute to everything that's in the divisor. Because the divisor is not just a number anymore. It's a polynomial. You place it underneath. So there'll be some work that goes underneath your dividend. And the biggest thing that students make mistakes on is that you have to subtract. You subtract, subtract, subtract. But if you end up subtracting a negative, you actually are adding. That's where the mistakes come into this. People forget that. Then, once you have this, it's like you got to restart. You're going to rinse and repeat, as they say. Look at your shampoo bottles. They all say rinse and repeat. So, I don't know why. You think one time would be good enough. And so, you do this again. You ask yourself this time, how can I make the leading term of the divisor equal, or by multiplication, the new line in the dividend? And you keep doing that, doing that, doing that, until you get to a point where you're not able to do that anymore through multiplication. Anything that's left over is called a remainder, and you place it at the end, divided by what you're dividing by. Those are the steps. This slide here, the only thing, guys, that I really want you guys to kind of look at is just this part right there. Basically, it says that if I take the divisor and multiply it to the quotient and add the remainder, I get the thing that we were trying to divide into. What's 8 times 3? Add the 1, it's got back to 25. Isn't that what we started with on our that first example that I gave you? So this whole idea, guys. Now, wait a minute. If I change this problem to say 8 divided into 24, your answer is just like, oh, there's 3, remainder 0, because 24 is 0, right? There's no remainder. And if there's no remainder, 8 and 3 are what of 24? Those would be called blank pairs.
Equal pairs.
Factor pairs. Would you guys not agree that 8 and 3 are factors of 24? Because they have a remainder of 0 when you divide one or the other into 24. We're going to use that to our advantage here. The polynomial division box, it's been basically explained by that colored line above. I say don't even look at that. You're going to get more confused than anything. Moving on. Let's do this, guys. Now, ladies and gentlemen, I would like you guys to use long division. I want you to divide this polynomial by the factor of x plus 6. Now, notice the wording on this problem. It's saying use long division to factor. It says factor each polynomial completely using the given factor and long division. What this means is that x plus 6 is a factor of that thing. And the results, that quotient, can be factored as well, and you'll be able to break this down into its smallest pieces. So it ends up looking like the problems we did yesterday, and we could graph it. And so, do I need placeholders in my polynomial? No. So I'm going to have x plus 6 divided into x cubed plus 7x squared plus 4x minus 12. Okay, here we go. How can I make an x equal to an x squared? X cubed, sorry. Multiply it by x squared. It's an x squared, guys. I am going to place it in the x squared column above. Now, has everybody got that? What I'm going to do now is I'm going to multiply that x squared to x to get x cubed. Multiply the x squared to 6 to get 6x squared. The next step says I need to subtract. Guys, I write this really big long line underneath all of that, and I write subtract. I do this every time on purpose. I need you guys to understand that you will be subtracting that second line from the first. What's x cubed minus x cubed?
0.
Gone. It goes away. We engineered that to happen. It should always happen. Then we got 7x squared minus 6x squared. It'd be an x squared. I then propose that you finish the rest of it, as in bring the rest along for the ride. Now, you start over. This is the repeat part. Now I ask myself, how can I make x an x squared? Multiply it by x. And now I multiply that. X times x, x squared. X times 6, and I will subtract. What's x squared minus x squared? Cancel them out. What's 4x minus 6x? It's a negative 2x. Bring the negative 12 along for the ride. And I get to do it again. Can I make an x a negative 2x? Multiply it by? Negative 2. What's negative 2 times x? What's negative 2 times 6? What happens when I subtract a negative 2x from negative 2x? Negative 12 minus a negative 12? So your remainder is? Now, wait a minute. The remainder is 0. That means that x plus 6 is a factor of x cubed plus 7x squared plus 4x minus 12. It also means, ladies and gentlemen, that x plus 6 times x squared plus x minus 2 should equal the inside part. Because remember, if you multiply them back together, you should get the answer, right? You divided it. Why can't I multiply them? The question was asking us to factor this. You factored out x plus 6. Can you factor the x squared part now? X. What are the factors of 2? 2 and 1. Have to add to a positive 1, but multiply to negative 2. Plus minus. This is now factored. I used long division to start it off, and I finished it by just factoring. So now you should be able to look at that and say, I know my zeros, I know the multiplicity, I know the shape, I know the degree. Graph it. You don't have to do that here. But that's what we're going for. Part B. I want you to try that on your own. Go. Okay, so do I need placeholders on this one?
No.
I do not. And I have to set it up. I have a nice column for everything. And now I have to ask myself, what is 2x? And how do I make that a 6x cubed?
3x squared.
3x squared. Now, I just have to multiply. What's 3x squared times 2x? 6x cubed. 3x squared times negative 4? It's negative 12x squared. This is tricky. 6x cubed minus 6x cubed is gone. What's a negative 2 minus a negative 12? It's 10.
Oh, yeah.
Because you got to add 12. So it's 10x squared minus 16x minus 8. And let's do it again. How do I make a 2x a 10x squared? A 5x. So I get 10x squared. Multiply it to 4. Negative 4 is a negative 20x. So therefore, subtract those, are gone. What's negative 16 minus a negative 20? It's a 4x minus 8. How do I make a 2x a 4x? Times a positive 2. And so I end up with 4x, 2 times negative 4, negative 8. And these will both, leaving you with a remainder of 0, which means 2x minus 4 was a factor of that polynomial. So that means 2x minus 4 times the answer I got, 3x squared plus 5x plus 2. And now all I have to do is factor that second quadratic, or that quadratic that's there. I am not going to finish this, but you guys should know how to factor quadratics, and factor quadratics that have a not be equal to 1. You have to do a times c. Find those factors that add up to 5. And then split it up, factor by grouping. Turning the page, we got to do these two. This is part C and D. It's a new set of directions on these ones. The directions just say divide. I'm not asking you to factor, just divide. For the sake of time, we should be able to do both. Okay. So, x squared plus 3x minus 4 divided into, do I need placeholders on this one? Not yet. The next one needs placeholders. The reason I chose this one was because the divisor has 3 pieces instead of 2. So it's okay that there's multiple parts in each one. But same thing. How do I make an x squared a 2x cubed? 2x. That's way over here. So I get 2x times x squared is 2x cubed. 2x times 3x is 6x squared. And 2x times negative 4 is negative 8x. Those are gone because I'm going to subtract. What's 5 minus 6? Negative x squared. What is a negative 7 minus a negative 8? Plus x plus 6. Question? How do I make an x squared a negative x squared? So I get negative x squared minus 3x plus 4, yeah? And I need to subtract. Negative x squared, and you subtract an x squared. Gone. 1 minus a negative 3. 4x. 6 minus 4 is 2. Guys, can I make an x squared an x? Not without dividing, right? So guess what? 4x plus 2 is a remainder. So the answer is 2x minus 1 plus 4x plus 2 all over x squared plus 3x minus 4. Okay? No big deal. Now, the next one we're not going to actually do. We're going to set it up though. Because do you notice that that big long polynomial needs placeholders? What's missing?
An x cubed.
I'm probably going to run out of room here. 6x to the 5th minus x to the 4th plus, oh wait, I don't have x cubes. 0x cubed plus 12x squared plus 15x. And then I have to have plus 0. That really got squished in there, guys. Then it becomes plus 15x plus 0. I need to have all the way down to even the constant having a placeholder. And then you just have to ask yourself, how do I make a 3x cubed equal a 6x to the 5th? Two x squared. And then just multiply through. Same thing over and over and over again. Your homework is the worksheet 2.3. I'm changing the directions. You guys have to do 1 through 6 and do long division for all of them. Have a great day.